just to wash the tubular from the scale or rust, usually using hydrochloric acid. For the matrix acidizing, which usually usually to clean the path or the channel of the flow, and this is usually using in the below the fracture pressure. Finally, it's a fracture acidizer, which usually to use the pressure higher than the fracture pressure of the reservoir to create a new channel to increase the productivity of the reservoir. So this is the picture just to show what I described of the criteria. The first picture is for just the cleaning the tubular. The second one for the matrix, and the last one is for the fracture, which to create a new channel. So what's the objective of this project? So to protect your the carbon steel tubular in the well from the corrosive material, which is acid, from the corrosion. So we have to use the corrosion inhibitor to protect the equipment and the tubular of protection. So the objective here to investigate the corrosion inhibitor, the functionality and the performance of in the acid solution at 1 molar HCl. So the corrosion inhibitor have been chosen lutecyl trimethyl ammonium chloride as a corrosion inhibitor for the carbon steel in 1 molar HCl. Here I wanted to give some information about the corrosion inhibitor. Corrosion inhibitor is a substance when we add it to the corrosive media, it protects the surface, and when we add it, we don't make any change of the media itself. Here, this is the lutecyl trimethyl ammonium chloride. It contains from quaternary ammonium. It's the nitrogen, which is the head group, and the tail, which is the organic channel. So what's the experimental technique that have been used to investigate the performance of the corrosion inhibitor? Electrochemical technique, which included linear polarization resistance. From this technique, we can calculate, we can measure the corrosion rate, and later we can calculate the inhibition efficiency. Potential dynamic polarization to know the mechanism of the corrosion inhibitor. Substrate analysis, which include scanning electron microscopy and X-ray photoelectron spectroscopy. This is the instrumental that have been used for the electrochemical technique. The first one is the EVIOM potential state. The second one is the multi-channel, which we can do 8 experiments at the same time. So what's the results from the electrochemical technique measurement? Here, this graph shows the concentration of the corrosion inhibitor versus the corrosion rate and the efficiency. So the blue line, it's the corrosion rate. We can see that the corrosion rate decreases by increasing the concentration of the corrosion inhibitor, while at the same time the efficiency increases by increasing the concentration of the corrosion inhibitor. So and it reaches more than 94%. This graph shows the results from the potential dynamic polarization. We can see here that there is not that much change in the potential, and we can see that the cathodic, from the cathodic branch, here is the cathodic branch, we can see the current decreases by increase the corrosion inhibitor, and because there is no that much changing in the potentials, that we can conclude that this corrosion inhibitor can inhibit the cathodic and anodic pointers, so it works as a mixed corrosion inhibitor. This is instrument shows the scanning electron microscopy, which gives us the image of the surface after and before adding the corrosion inhibitor in the solution. So from the scanning, these images we collected from the instrument we showed before. So the first picture is a polished carbon steel. So this we can see it's very soft. When we put the sample in the hydrochloric acid, 1 molar hydrochloric acid, the surface is very rough. And the last one, we can see after adding the corrosion inhibitor, it's almost 2 millimolar in hydrochloric acid. We can see that the surface is smoother than before. It's not smooth like a polished sample because we cannot control the corrosion inhibitor to reach 0. So just the efficiency as we saw before, that reaches 94%. This is for X-ray photoelectron spectroscopy. This instrument is for Galox Access Ultra X-ray photoelectron spectroscopy. This is for it's the criteria of this is it's photo in and electron out at a specific core level, which we can record, which this instrument can record the binding energy to see the element and the chemical on the surface, elemental and chemical composition. And after that, it gives us a spectra. So this is the binding energy. So each element here has a specific binding energy. We can see that the polished sample, which is the black spectra, there is the iron which related this element appear because the originated from the carbon steel. Also the carbon is appear here because it originated from the contamination of the surface. Another one is the oxygen, which originated to the oxide of the surface. And we can see here that the nitrogen is not appeared before, but later at the 50 millimolar, the spectra of the nitrogen is appear, and this is give us an indication that the nitrogen is absorbed in the surface, and the nitrogen originated from the corrosion inhibitor, as we showed before, the structure of the chemical. Here is specific, each graph shows the specific element, how it's, how it's changing by increasing the concentration of inhibitor. The first one is for the, the first one is for the nitrogen. We can see that the polished does not appear, and after that, the nitrogen, which labeled as N double dash, is related to the corrosion inhibitor, and we can see is the intensity of the nitrogen is increased by increasing the corrosion inhibitor. For the iron here, in the beginning, the iron, the binding energy is 705. So after that, we can see that the spectra is increased by increasing the corrosion inhibitor, and we can just here. This is related to the oxide. So when we immerse the sample in the hydrochloric acid, this oxide will disappear because it's dissolved. As we can see here in the oxygen, in the beginning for the polished, the oxide spectra, which the oxide and hydroxide is appear, and after that, when immersing in the hydrochloric acid, is disappeared. We can connect both these figures and remove the oxide, and after that, instead of the oxide, now there is a salt which appear when we immersing in the hydrochloric acid instead of the oxide. This cartoon just to show that the polished sample which contained carbon steel and iron oxide, the second block, which the concentration of the inhibitor from 0.1, that the carbon steel and iron chloride, which instead of the hydroxide after immersing in the hydrochloric acid, and the absorb of the chemical is less here. And finally, when we added the chemical until 2 millimolar of DD2MAC, we can see that the chemical absorb on the surface and protect the surface. Finally, we can conclude it here that this corrosion inhibitor, the efficiency is increased as the concentration is increased until to reach more than 94% from DD2MAC, that from the BDB. So that this DD2MAC, it works as a mixed corrosion inhibitor, can inhibit the anodic and the cathodic side. From XPS here, we can indicate that DD2MAC absorbed in the surface. So this seems apparently from the high resolution of spectra of the nitrogen. So we can conclude that DD2MAC can absorb from the surface and significantly inhibit the corrosion during the acid job. Thank you for your attention.
Thank you very much, Ms. Julia, for the interesting and very specific topic in production engineering. Any questions from the audience? Gentlemen, first row.
Oil and gas. Just a couple of questions. Okay, can you give us an idea how much money the company saved after using this product? And if there are any specific measurements that the company has to take for the process after injecting this product? Thank you.
The cost of the corrosion inhibitor itself.
You know how much you saved after using this product. Because if you are corroded with makes your fuel, your pipeline, etc. How much this product has saved you? And is there any specific measurement for the process after injecting this?
I showed that when we added the corrosion inhibitor, I showed that without adding the corrosion inhibitor, we show that the surface is corroded completely, because you know that you have to use the hydrochloric acid during the acidizing. So during the acidizing, the tubular, you will lose the tubular and the equipment. So you have to use the corrosion inhibitor to be your equipment and to be your equipment safe during this operation. So this is, I have worked on this corrosion inhibitor in the lab, and I collect all the data from the lab. So the efficiency of it can protect your equipment around 94%.
Another question?
Thank you, Ray, for interesting presentation. Just a simple question. We used to use the corrosion for the producer wells. How about the injected wells? For the injected?
Injected with?
Yeah, corrosion inhibitor.
So
So,
use the acidizing or what?
for inhibitor.
This corrosion inhibitor, specifically organic corrosion inhibitor for the acidizing, to protect the surface. But for the injection, you need for water itself. So for water, there is corrosion inhibitor for water. There is oil corrosion inhibitor, water corrosion inhibitor. It's different.
Thank you very much.
to thank you very much again, Ms. Sturia, for the interesting presentation. You gave a very clear example of everything that worked in mission. I think that brings us to the end of the program of this morning. I think it's time for lunch now. I would like to thank the attendees for being here and asking questions and being an active audience. I'd like to thank the presenters for sharing their views with us, and I wish you a very good continuation of the conference. Thank you very much.
Oh no, I mean that if you see him tomorrow, then when you're back home.
No, not tomorrow. I will back. But
Whatever
okay,
it is.
I will
Yes.
see him. There,
Give
there
him
is
a-
anything?
Thank you. Yeah, thank you. So you were in school. Yeah.
University.
Yeah. I was at Delft University. The other technical university.
I had some courses. Someone just what do you think about concept recently? What are they streaming?
Live streaming.
Ça va.